Okay, we're going to work today with chapter 15A, B, C, D, and E. All of these sections in the textbook cover right triangle trigonometry, which is a review topic from geometry last year. So we are still within topic 5, geometry and trigonometry. Last time we talked about volume and surface area, and your formulas for volume and surface area are down here. One thing to take note of whenever we're dealing with our trig ratios, what they don't have here is that SOHCAHTOA idea. So from geometry you had sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. They don't provide that in here. So they provide these rules, which we're going to work with next class. And even in the review topics, they do not tell you your trig ratios. So that is something that you're going to have to know. So whenever we have a right triangle, there are relationships between the sides and angles that remain constant. So here's my right triangle. If we called this angle angle theta, meaning that's our reference angle, the angle that maybe we know, we can label our triangle off of this angle. So first, I always label the hypotenuse first because it never changes. So the hypotenuse is across from the right angle. It's also the longest side. So this side is the hypotenuse. After that, you have to go to your reference angle. The side across from your reference angle, across the triangle, it's called opposite. And then the side next to it is adjacent. So reference angle here, opposite, adjacent, hypotenuse never changes, it's across from the right angle. If you label your triangle this way, we have some nice ratios that remain the same. And those are our sine ratio, cosine, and tangent. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The little words you might have learned in order to remember how these go is SOHCAHTOA, and it goes like this. SOHCAHTOA. So this is sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So these are the ratios that go with each of these. So let's start with an example. Have a right triangle. Call this theta. That's my reference angle. And I'm going to label my sides. And I want you to set up your sine, cosine, and tangent for that angle. So we know the ratios, we know which sides we need for each, but on our triangle we need to figure out which side is which. So like I said before, I always start by labeling the hypotenuse. Hypotenuse is the longest side in the triangle. It's across from the right angle. So this is my hypotenuse. We go to our reference angle and we do opposite side next. So here L is opposite, it's across the triangle from our reference angle, and M is the adjacent side. After you have that labeled, it's just a matter of knowing which goes with which. So since sine is opposite divided by hypotenuse, our opposite side is L, our hypotenuse is N. Since cosine is adjacent over hypotenuse, our adjacent side is M, our hypotenuse is N, and we divide them. And last, our tangent is opposite over adjacent, so it's L over M. So that's how you label your triangle. You always start with your hypotenuse, then you label your opposite and your adjacent side, and then your ratios each involve two of those sides being divided. So why do we care? Why does this matter? We can use this concept to solve for missing information in right triangles. So I'll draw this little triangle here. So I've got a right triangle. That angle is indicating that it's a right triangle. I've got a leg of x and a leg of 5. This angle is 42 degrees. I want to find the x, that x value. I want to find that length. Okay. I don't have enough information to use the Pythagorean theorem. In order to use the Pythagorean theorem, you have to know two sides and be looking for the third. But I only know this side. So if I knew maybe this side also, then I could use the Pythagorean theorem. But since I don't, we're stuck with using our trig ratios. So I need to label my triangle to determine what ratio I want to use. So hypotenuse is what I always label first, is across from the right angle. Since I know this angle of 42, I'll call that my reference angle. X is opposite of that. It's across the triangle. And that leaves the 5 to be our adjacent. So I don't know the hypotenuse, and I also don't care to know it. What I do know is the adjacent, and I want to know the opposite. So when choosing my trig ratio, I'm thinking about what I know and what I want to know. So opposite and adjacent is going to be tangent. Tangent is opposite over adjacent. So I write, and I actually like to write the whole thing, so we know where everything goes. So tangent is opposite over adjacent. Theta stands for my angle, so tangent of 42 degrees equals, opposite is x, adjacent is 5. This is where we make sure your calculator's in the correct mode. So whenever I type in tangent of 42, if you do not get this decimal, you need to change the mode. So there's actually two ways that we can measure angles. We can measure them in degrees and also something called radians. So if you get a different value, it's because your calculator is in radian mode. So to change it, you click mode, and then right here, if radians is highlighted, you scroll over and highlight degrees. Second mode gets you back to the home page. Okay, so if you're in the wrong mode, you're going to get this decimal. That's not right. Okay, we're in degrees, so we need to be working in degrees, and you should get that. Okay, 0.9004. So tangent of 42, this side of the equation, is 0.9004. And we solve this equation for x by multiplying by what's on the bottom of this fraction. So since it's being divided by 5, we multiply both sides by 5. There's no point in rounding. I have that decimal on my calculator, so just type times 5. It makes your answer more accurate. So x is equal to 4.502. So in 3 sig figs, 4.50 centimeters. All right, let's work through another one. Oh, sorry, didn't know I was off the screen. So there's our little triangle. We want to find x. So, what do we do? Let's see. Do we have enough information for the Pythagorean theorem? We do not, because we need two sides and we only know one. We want to find this side, so we're going to think trig ratios here. I'm going to start by labeling my triangle. So we go opposite of the right angle, it's the hypotenuse. Since this is the angle I know, that's my reference angle. So 13 is opposite of it. It's across the triangle from it. And that leaves the side we don't know to be adjacent. Just a kind of quick reminder while we're at it, you don't have to use this angle, you could use this one. You just have to remember that the three angles in a triangle add to 180. And so we could find that angle by doing 180 minus 90 minus 31. So 59. Okay, so if you wanted to, that's 59 degrees. You could use that one instead. You'll get the exact same answers. It's nice how that works out. So let's figure out what trig ratio to set up. I don't care about adjacent. I don't know it, and they don't ask me to find it. What I know is opposite, and what I want to know is hypotenuse. So sine is our choice. Sine is opposite over hypotenuse. So we're going to set that one up. Sine theta equals opposite over hypotenuse. Theta stands for my angle, so it's 31 degrees. My opposite side is 13. My hypotenuse is x. Sine of 31 can be found from your calculator. So sine of 31 is this decimal. So 0.515. We could go 0.4 we wanted. Now, we always whenever we're keeping an equation balanced that has a fraction, we always multiply by what's being divided. So the thing that we're dividing by is x. So in order to solve for x, we have to multiply it by it. Just like up here, the 5 was on the bottom, so we multiplied by 5. Down here, the x is on the bottom, so we multiply by x. This question has one more step. So now we have this equals 13. And we can divide our decimal value off to get x by itself. Once again, we had to round to write this number down just to save time and space, but it's right here. So whenever I do 13 divided by, use your second answer. It keeps that decimal from being rounded and gives you a little bit more precise answer. So x here is equal to 3 sig figs would be 25.2 inches. Alrighty. Not only can we use trig to help us find side lengths, we can also use it to help us find angle measures. So let's do an example of that. So, example. We got a right triangle. That's the angle we're going to want to find. So we've got 5.7 meters and then 3.7 meters there. And we want to find the value of theta. We want to find the value of this angle. So, in order to find an angle, we're going to have to use a trig ratio here. So, we need to label our triangle. I always start with the hypotenuse, which is across from the right angle. This is the hypotenuse. Then, since this is the angle I want to know, it's my reference angle. The 5.7 is opposite of that, and the 3.7 is adjacent. So since we're trying to find our angle measure, we need to know both sides that go within the ratio. So I know both the opposite and the adjacent, so I want to use tangent for this. So I always set up tangent theta equals opposite over adjacent. Plug in everything I know. In this case, we don't know our angle. That's what we want to find. My opposite side is 5.7, and my adjacent side is 3.7. This value over here we can get from our calculator. So 5.7 divided by 3.7 gives me this, 1.54. I don't want to round too much, right? 5405 maybe. And now we know the tangent of some angle is equal to this decimal. Tangent of some angle is 1.5405. In order to find the angle, we have to go backwards. We have to go from here back to here. In order to go backwards, we use the inverse button in our calculator. So in my calculator, I'm going to type tangent inverse of 1.5405. And this will give me my angle. Okay? So if you type tangent of a number, I don't know, 52, that tells you if the angle is 52, this is your ratio. If you type second tangent, let's say I use that same 1.279941632, it tells you the angle that goes along with it. So it goes back and forth between those two values. So in this case, I know my ratio, I know my decimal, I want to find my angle, so it's second tangent, and I should have kept that decimal, so 5.7 over 3.7, so we don't round, is this. Second tangent of that answer is 57.01. If you just pressed this, just tangent, you're going to get like this weird, that doesn't make sense, for an angle measure. That's very small. The 57 makes more sense. So theta is equal to 57.0 degrees. All right, the last question we need to do deals with an isosceles triangle. So isosceles is a definition that you have heard before in geometry, maybe even before that. And what an isosceles triangle is a triangle where two sides are the same length. So this is an example of an isosceles triangle. So I'm going to say we want to find this side, and our bottom side is 5 meters. Unfortunately, this isn't a right triangle. So, also I meant to label this. Which angle did I want to label? This one. Okay. Unfortunately, this isn't a right triangle, so we can't just jump straight into trig. However, we have some properties of isosceles triangles that are going to help us out. So the first, in an isosceles triangle, the base angles are congruent. So our base angles are the same size. That means if this one's 74, so is that one. Okay. In addition, we know that the angles within any triangle add to 180. So to find this angle, we can take away 74 and take away 74, and we get this angle to be 32. So the three angles in any triangle add to 180. So sometimes whenever you're doing a question, you can't go straight to finding what you want to find. You have to figure out what all do you know, and then try to work to get there. So it doesn't seem like I'm making much progress, but what I have found is going to help. We have this other property of isosceles triangles that says that if you drop your altitude, which is a perpendicular line, from this point up here, in between your two congruent sides, it cuts this down here in half, and it cuts this angle in half as well. So if we drop this line here, this altitude, it sort of breaks it into two triangles that are the same. So we can see how we've now introduced some right triangles here. And we've got a lot of information about them. So one thing we know is this side length, the whole thing is 5, but by dropping this, we've cut it in half. So that's 2.5, and this would be 2.5 as well. In addition, we've cut this angle at the top in half as well. So half of 32 is 16 degrees. There's a lot going on in our picture. So I'm going to take this triangle, break it into just the stuff we know about it. This is now in a similar place that we were in, not on this example, not on the one above with the angles, but on the page before. Where we're trying to find a side length, but we only know one other side length, and we know some angles. So we can call either one of those angles our reference angle if we would like. It doesn't matter. It does not matter at all. Okay, so if you want to pick one or the other, go for it. I'm going to start with 74, since that's the one that was given to me. I can be a little more confident that it's correct because it was given, where this one I found it. So I'm a little more confident with the 74. So I'm going to pick that one. Across from the right angle is our hypotenuse. Across from our reference angle is the opposite, and that leaves this one to be adjacent. So in order to find x, we're going to set up adjacent and hypotenuse, which is cosine. Plug in everything that we know. So our reference angle, we made 74. Our adjacent side is 2.5, and our hypotenuse is x. Our calculator can do cosine of 74, which is this decimal, 0.2756. since it's the x that's on the bottom of that fraction, whenever we multiply, we have to multiply by x. 0.2756x. And then we divide off this decimal. Once again, keep any numbers you possibly can in your calculator for accuracy. So this is going to be 2.5 divided by this decimal. And there it is. X equals 9.0. So 3 sig figs would make that a 7. And we are in meters. I know this is a lot, but this is all review from geometry. So please do what you can. Work through this topic. Trig is a very popular topic on the IB exam. The trig that we did here, in addition, next time and the time after, we're going to keep working on topic 5. And we're going to do some other things with trig involving sine rule, cosine rule, and area of a triangle. But big topic on the IB exams. These are the ones that we hit. So last time was volume and surface area. This time, remember, your ratios here are not in the IB book, so you do need to know these. And then we're going to move from here. So thank you for watching. As always, please ask me as you need some help.